Basically, I'm interviewing with one of the FANG companies, and if you know how hard to interview in these companies are, so it's not about just having a good problem solving skills. It's also about explaining the interviewers how you are thinking and basically impressing with your performance. So it's less of a problem solving exercise, more of a reminding and problem performance exercise. Yeah, so what I decided, I'll be solving some lead code problems live when I'm recording myself solving them. This is a nice practice. I would definitely suggest you to do that. I guess there are already some people who have been doing it on YouTube. You'll likely find many people who are doing it. Yep, so I have resetted this problem. This is a classic two-sum problem, which is quite common and quite famous in Leetcode. You can see the 60,000 likes on it. So the problem, what is the problem? Let's read the problem first. It's very important to understand what the problem is asking. I recently had an interview where I confused a bit in what was asked, and yeah, that indeed landed up as a criticism, whatever you call it. So yeah, if you don't want to do that, make sure you read everything properly. Right. So we have given an array of integers, nums, and an integer called target. Return indices of the two numbers that they add up to target. Right, so we are giving a numbers list, which is they have given an example of, and then again another number, which is a target. We need to find the two numbers from this list, which will be adding up to 9. So it's very easy to point out here that 2 and 7 would be our answer, and we need to return their indices. So remember that the devil in the details. Yeah, just pretty focused to that. I didn't say that properly, I know. Yep, but hold on. They also say that you may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Right, so when they say that they don't want us to use the same element twice, I guess they mean when they have, like, they don't want us to use this number 7 twice, for example, because they have also given an example down here where we see 3 3. You might say that this is the same number, then why we are considering them. So yeah, that's just a gotcha here, and you'll have to take care of it. Anyways, so any FANG, or at least the company I'm interviewing, they expect you to explain how you're going to solve the problem, and it's really important before you type into coding, and they don't really like it when you start writing code without explaining what it's going to do. So yeah, let's try to draft a solution. So here's my input. I take the numbers array, I shove it in here. Oops, I ran that by mistake. So this is my nums array, or the list. Then I'm given with a target, and my target is 9 in this case, in the first example. So how do I find two numbers which add up to 9 in this list? So let's say we start at index 0, and we check the next number is 7, and we add those both, and we can say the number is 9. That is a nice first thought and observation that we can see. But it could happen that we have, let's say, 7, instead of being here, it's at the last element, for example here, not 17, 7, right? So in that case, how do we keep track of the indices? It will be like, we might use a 2-pointer thing here, like we have the pointer as j, pointer at the end, pointer at the start, and then we keep on increasing the pointers. But what would be the criteria for increasing the pointer? We might be able to sort the array, and then we might be able to, so let's say if 2 and 7, let's say this element and this element is not, for example, there's an 8 here. Oh, let me first sort the array. Yeah, you don't want to do what I'm doing right now. I'm confusing and keeping contradicting statements, which is a really bad thing in interview. So yeah, let's say we have this sorted array, which we don't want to do ideally, because that will add up extra memory complexity, space complexity. But let's say we have this area sorted, which is not in our case. So I can check like this is my start index, this is my end index or pointer, and then I check if 2 and 15 are adding to 7, adding to 9, and then the answer is no. So what I can do, because my target is less than my current sum, I can reduce my right pointer to 11, my left pointer stays here, and I would check if 2 plus 11 is equal to 9. No, it's not. Then again, because 2 plus 11 is 13 and it is greater than 9, I would move my right pointer to left by 1, and then I have my left start pointer still here, then I have my 7 pointer till here. This might do it actually, but the only thing about this is I need to have like sorting, which is n log n, and yeah, sorting just alone takes n log n, and then again I need to go through all the items, which is like n log n plus n, which is basically n log n. But can I do better? So let's say we don't sort the numbers, we keep the numbers in the order they are. Let me put it back. Actually it was sorted in this case. Yeah, actually I can see the numbers are sorted, but they don't promise us that it will be sorted. Yeah, so I guess let's not assume just because the examples are given in sorted order. So yeah, back to the step 0, I guess. So we can't do the sorting. That's why we can't use 2 pointers, because otherwise how do we decide when to move the left pointer, when to move the right pointer? And yeah, how do I do that then? So what we can do in this case is, let's say we start from the 0 element, which is 2 here, and we subtract it from 9, because 9 minus 2 will give me 7, which is my diff, right? And once I know which number I need to find, I can try to look up that number in my rest of the list, but doing that would make it n square, because what I'm doing, I'm going to this number, then for the number, the diff I got from that number, I need to search it in the whole list. So definitely it's worse than the sorting solution we have. So let's not do that, but we might be able to store this. What if we reduce the cost of looking up this number in the list? We can probably do that with a map. So let's say we maintain a diff map which will contain this diff and the index at which we saw the diff. So that way I can, whenever I see the number I am trying to find, the diff I'm trying to find, I can simply check that diff exists in the map, and that diff was, let's say, existing for the 0th index, and then I can find the index of the element which would make it to 9, and I can return those indexes. Yeah, sounds good. So that would look like similar to this. So diff mapped against the value index, which is giving me the diff. In this case is 0, and yeah, same, I can continue doing that unless I found that diff is present in the map, right? Yeah, because adding to map and reading from the map is constant time operation. I think I can do this with or what I think it can be done in O of n, because I'm visiting every item once. I'm checking the diff, and basically checking the map, which is giving me O of n worst case. All right, so let's start coding this one. I have my index, which is 0. Then I need the diff map, which is an empty map at the start. Then I have my actually I don't need any extra variables here. I can initiate my map. I can say while I is less than the length of the nums, because I don't want to cross my bounds. And I need to calculate the diff, because that's how I store it or look it up in the map. So nums of I to be subtracted from target. So target minus nums of I got my diff. Now I do need to check if there's a diff present in the diff map, because that way I know that there was a number which was equal to the current number, and actually not the diff, the current number. So there was a number which was giving me diff is equal to current number, and that way I can return the indexes. So if diff map, or actually if nums of I is in the diff of I, or diff map, and if that's the case, I return the index which where I found the diff, and my current index. Yep, this should do it. And also, if that's not the case, I didn't have a diff existing in the diff map, I also need to put that diff map, the current diff into diff map, which would be diff map current diff, and the map, the key will be the diff, and the value will be the key, the index, I mean. So yeah, that's there, and I think that should solve it. Like I said, they expect us to not use the same element, but we are fine with using two elements at different indexes, so you don't have to do anything special about it. Right, let's run through the code once. So target remains same. Let me reset my diff. Let's reset our diff map. Let's have our pointer at 0. Then this is initialized. I'm running through my list where I is equal to 1, or actually I forgot that I also need to increase my I, otherwise it will be stuck in this loop forever. So I got my current number as 2, my target is 9, so diff would be my current number minus my target minus current number, which would give me 7. Now the 7 is not in the map here, so I put 7 and my current index, which is 0 in this case. That's done. Now I'll increase my I. Actually, it's a good idea to keep the variables in order they are accessed in the call stack. Just keeps it easy to visualize it and basically run through the code. Right, so I is equal to 1. Again, I'm in the loop. I calculate the diff 9 minus 2 is equal to 7. Now I need to check if this 7 9 minus 7, that is 2, and I don't have to check the diff. Actually, I need to check the current number if it's present in the map. So 7 is in the map, so I simply return my indexes, which would be in this case the diff index, which is 0, and the current number index, which is 1, which matches the value here, and yeah, it ends here. We can probably take another example. This is too simple. Probably take this one. So let me reset it again. My target is 9, diff is reset, my diff map is reset, the return values are reset. Right, I'm at it is 0, 3, my diff is target minus, actually target is 6 here. So 6 minus 3 is equal to 3. I don't have the diff in the, one second, I don't have current number in the diff map, so I put current diff with the index 0 in the map. Then I go to next number, which is 2. My I is increased. 6 minus 2 is 4. I check if my current number is present in the map. No, it's not, so I put my diff and the value here. I increment my I counter. Then I go to the last value in the map, which gives me 6 minus 4 gives me a 2. I check if 4 is present in the map. Yes, it is. So in this case, I return the index of the number which is present in the map and the current index, which is 2. Right, and because I'm returning already here, the diff map won't be updated, so it remains like this. Yeah, that's how it will work. And I guess we can run it now. Right, there's a typo, I guess. What it's saying, key error, so it didn't found the 2 in the map. That's probably because I didn't put my current. One second. Oh yeah, because I'm checking the number and accessing the diff, which is wrong. Right, yeah, there you go. We solved it, and let's submit it. Hope everything works. Nice, beats 100%. And yeah, like I said, should be a big O of n. Yeah, there we go, solved it.